Hi, my name is Steven, and today I'm going to talk about the predictive modeling pipeline for the telco customer return challenge. So for the hackathon, the first step was building a highly accurate model. So to safely deploy a machine learning model in a real business setting, we have to completely open the black box. So I'm going to walk through the methodology, which is built around responsible AI fairness and explainability. So I began by elevating the raw data using clinical business logic. First, I ran an isolation forced algorithm to detect and isolate the top 5% of highly anomalous customer accounts, which showed completely different trend behaviors than our baseline. Next, instead of blindly feeding raw columns into an algorithm, I engineered contextual business features. So I created a price spike flag to catch customers coming off of cheap promotional pricing who are currently experiencing bill shock. I also engineered an ecosystem stickiness index to measure how deeply entrenched a customer is in our extra services, which mathematically captures their psychological switching costs. To validate performance, I used an 80-20 split, and I trained two competing architectures, a deep learning neural network and a random forest classifier. So we ended up using the random forest model for deployment because of two reasons. One is that the tree-based models offer better intrinsic interpretability, which is mandatory for responsible AI. Second, I was also able to make the random forest cost sensitive. So by weighting the training samples based on the customer's monthly charges, I forced the algorithm to prioritize the retention of high-paying VIPs over low-tier accounts. Coming up with a prediction isn't very useful without an explanation. So to understand how the model behaves at a company-wide level, I utilize SHAP values. So the SHAP summary plot showed the short tenure and high monthly charges are our biggest systemic risk factors. I also generated the partial dependence and individual conditional expectation plots. These PDP plots gave me the exact mathematical threshold where a customer's tenure finally stabilizes their churn risk, providing the marketing team with a precise timeline for when they can safely reduce their retention spending. So while global metrics are great to see the big picture, customer service reps need individual insights. To solve this, I implemented Lime to generate local instance level explanations. If the model flags a specific person, for example, someone like customer ID 5 has a high flight risk, the Lime output explains why. It breaks down which specific features push their score towards turning and which pushed it towards staying. This turns a complex machine learning prediction into something more actionable and something that agents can use when trying to convince them to stay. One of the big requirements of the project was ensuring responsible AI usage. I had to audit the model to ensure that it wasn't biased. So basically, I tested whether the model was disproportionately triggering false positives for senior citizens compared to younger demographics. I isolated the test predictions and mathematically calculated the false positive rates for both groups. The disparity was well under the 10% safety threshold, proving the model is making fair decisions based on contract behavior rather than age-based demographic bias. Finally, one thing to consider is the ethics and realities of production deployment. Ethically, just because we can predict someone will leave doesn't mean we should use aggressive, high-pressure sales tactics on them. Predictions should trigger rewards based on activities, something like loyalty discounts to respect our customers' autonomy. To make the pipeline production ready, we can't just deploy it and walk away. You would need data-driven monitoring to track consumer behaviors over time and an automated continuous integration or continuous development pipeline to continuously retrain the model based on the real-world success or failure of our interventions. Thank you.